Good morning, Year 7 mathematicians, and welcome to another lesson on adding and subtracting fractions. So if you just draw a line under the work you've done previously, pop on today's date and the title of Adding and Subtracting Fractions. Now your do now task is a continuation from last time with the same denominators. So James, Simon and Chris have ordered 2 pizzas to share. James has eaten 5/8 of a pizza, Simon ate 7/8 of a pizza, and Chris ate the rest. I want you to show me what fraction of the pizza did Chris have to eat. And then when you've done that, it's a little bit of a bonus here. Would you be able to work out from here as well how much Chris ate if Simon in fact took 14/16 of the pizza? Simon ate that amount and Simon then ate that amount as well. So if you pause the video there and have a go at that do now task for me, spend a couple of minutes on there for me. Okay, so hopefully if remembering from last time, if we've got 2 whole pizzas, we're going to take away 5/8, we're going to take away 7/8, and then we can have 5/8 minus 7/8, add those together, that's 12/8. 2 whole ones, 16/8 minus 12/8 leaves us 4/8. It's the amount that Chris then got off the pizza. That's obviously more commonly known as half of the pizza there Chris got. A little bit shortchanged, didn't get as much as the rest. In the orange box there at the bottom, we'll come back to those. If you've had a go at them, fantastic. But we're first going to have a look at doing adding and subtracting fractions with those different denominators. Now we've got 16, and then hopefully you can go back and correct any of those if we've made any mistakes there. So what we're going to look at today then, as I say, add and subtract fractions that share a common multiple. So they've got a different denominator, but we're looking to get a common multiple to find that, and then that enables you on the final part to answer, in effect, any addition or subtraction fractions. So, one of the key things here is equivalent fractions. Excuse me. So, we're going to see how we work these out then. What does equivalent mean? And see if you can work out how many fractions you can find for a half that are equivalent, and then how many you could find for 1/3. And see if you can note a relationship between the numerator, so that's the top part of the fraction, and the denominator, the bottom part of the fraction, in those sets of equivalent fractions. So just write down as many as you can in the next 2 minutes on those. If you're unsure, just have a little think about what equivalent means, see if you can get a definition, and then we'll look into that shortly. Okay, so hopefully you've filled up your book with a fair few of those fractions for me now. So we'll move on and we'll try and give a bit of a definition in a moment for that. So, this is a lovely fractional wall there, and every single section of it is equal. So the 2 halves, we should know, make up 1 whole. The 3/3 make up a whole. 4/4 make up a whole, and so on, all the way down. We've just stopped at 12 as well, so you could keep that going. Okay, so we need to see what equivalent means. So, equivalent fractions have the same value, even though they may look different. So a half is actually equal the same as 2/4, and that's then the same as 4/8. They are called equivalent because they are exactly the same. They take the same value, but with either multiplied or divided both, and that's the important part, the numerator and the denominator by the same number, the same amount, so the fraction keeps its exact same value. So to get from a half to 2/4, we've just multiplied the numerator and the denominator both by 2. Likewise on the next one, 2/4 to get to 4/8, we've multiplied both sides by 2. So it's still in exactly the same proportion there, and that is called an equivalent fraction. Okay, equivalent fraction there. So we're going to have a go at doing some of these for us shortly, but first of all, here's another one of these lovely diagrams. See how many ways you can express the fraction below. Okay, how many different ways can you write that down? I think we'll just take 60 seconds if you pause the video, and you should be able to get, I think, sort of, there should be sort of 3 or 4 there you can get down relatively quickly for me. Okay, so having a look at this then, if we were to take those as 4 individual columns, we could perhaps say there was 3/4 there as a fraction. If we were to split it all into the 12 squares we can hopefully see there, we could say that is 9/12. If we split it even further into the 24 triangles, we could say we've got 18/24 total. Again, all those three are equivalent fractions. They all show exactly the same thing. We've just multiplied or divided by the same amount on numerator and denominator to get those equivalent fractions. So hopefully this one then becomes a little bit clearer. Mo says 10/20 is twice as big as 5/10. Do you agree? And why, or why do you perhaps not agree if you think Mo is wrong? So looking on this one, we should see then, what have we done to 5/10 to get to 10/20? Yes, we have multiplied it by 2, but everything has been multiplied by 2, both the numerator and the denominator. So in fact, those are equivalent fractions. They're not twice as large there. 10/20 is not twice as big as 5/10 because, yes, we've multiplied the numerator by 2, but we've also done that to the denominator. So they're exactly the same value there. Okay, and there's a bit of a fractional rule there you could use. We've said 5/10. If you look along the tens there's 5. The number of 20s there, you've got the same as 10/20, just to prove it there with our fractional rule once again. Okay, so here's a couple more of equivalent fractions there, and you can use the bar model again if you wish to show these equivalences. Okay, equivalence is just the plural there of equivalent. It just looks a bit of an odd word when it appears. So explain the relationship between each pair of equivalent fractions and how this connects to the bar model. Okay, so just give you a chance there to write those three equivalent fractions down there. If you wish to, by all means, you can sketch out some of the bar model for that, and from the fractional rule that we've used there as well, and then just explain that relationship there between them. What have we done to each of those? Okay, so hopefully on that first one, 2/3 to 4/6, we can see we've multiplied by 2, both the numerator and denominator. The second one, we've multiplied both by 3. And the last one, we've multiplied both by 4. And we've done it, most importantly, to both numerator and denominator to keep them the same value and equivalent. Okay, 4 equivalent fractions then for each of these below, A, B, C, D, and E. And then when you've done those, write down 2 equivalent fractions that are the same for those decimals. See if you're comfortable in the conversions there. Now, when it says 4 equivalent fractions, there are, well, in theory, there are infinite answers. So just put down a bit of a nice variety for each of those. Give yourselves 5 minutes to do that, and then we'll come back and I'll put up a variety of answers for you. Okay, so a third. So these are just some examples you could have gone with. So I've gone with 2/6, 3/9, 10/30, and 100/300. Okay, so all exactly still the same value. Answers for 3/4, 4/5, 3/10, and then 1/8. I say if you haven't got those exact answers, don't worry. You just need to see, have you multiplied both the numerator and the denominator by the same amount? If you have, then they're equivalent fractions. Okay, a little bit more tricky was the bottom 5 there with decimals, was converting the decimals first. So I think the first answer I've put is exactly what the fraction is for that decimal. So the first one, 0.7, 7/10. We could say that's 70/100 as well. 0.5, hopefully we'll recognise as a half. 0.25 is a quarter. I've jumped straight in with 10/40, but yes, that's a quarter. D, 3/4, 3/4. Last one, E, 15/100, or we could write that then as 3/20. Okay, a few teacher-led examples. So when this comes up, you need to make sure as well you've got these written in your books as a nice solid example. So, why is 1/10 plus 7/10 easier to calculate than 1/10 plus 7/15? We should know from last time that when we're adding fractions with the common denominator, which was 10 on the example here on the left, It's very simple. We just add the numerators. 1 plus 7, we know that's 8 over 10. When we've got a different denominator, the 10 over 15 on the second part of that, it becomes a little bit more tricky. So we need to get them to have the same. We do this by looking for the lowest common multiple of each of the pairs of numbers. Okay? So we need to have a little bit of practice to identify the lowest common multiple, which are often referred to as LCM, of a pair of integers, our whole numbers, when adding and subtracting fractions. Okay? And I want you to have a little think here. By looking at those pairs of numbers we've got, so 3 and 12, 15 and 20, 6 and 9, and then 12 and 18, I'd like you to write down the lowest common multiple of each of those numbers, or each of those pairs of numbers, sorry. And then, as an afterthought here, you can find the lowest common denominator of a pair of fractions by multiplying their denominators. Is that always true, sometimes true, or never true? Okay, so fill in those lowest common multiples and then have a go at that last bit to see if you've got an answer to that for me. Okay, we'll come back then. So hopefully we've got for lowest common multiples, first one we should have is 12. Okay, when we talk of multiples, lowest common multiple, that's your multiplication table. So what's the smallest number that appears in both multiplication tables? 1 times 12 is 12, and then the 3 times table, 3, 6, 9, 12. 12 appears first in those. 15, 20, get to 60, 18, and then the last one, 36. So you can find the lowest common denominator of a pair of fractions by multiplying the denominators. Now, for the 4 examples we've got there, none of those were true. You wouldn't do 3 times 12, that would have got you 36. There's a much lower common denominator. Okay, so for that basis, it would look like it's never true. It's clearly not going to be always true, because we know we haven't got any examples yet. It's actually the middle, and it's sometimes true. So say, for example, you're looking for the common denominator of 3, the lowest common denominator of 3 and 4. Okay, 3 times 4 is 12. The lowest common multiple we're going to get, going through the 4 times table, 4, 8, 12, 3, 3, 6, 9, 12. So it will occasionally work. And if you are struggling, a nice simple way is to multiply your denominators together. Okay, so let's put this blue box down. To add or subtract fractions with different denominators, change them to equivalent fractions with a common denominator. That's the key part that we need to know from today. If they do not have the same denominator, we need to make them the same by getting equivalent fractions. Okay, and then there are 6 questions there. I would like you to find the equivalent fractions for those 6. So if you write those down, the full question in your book with that box, you fill in the number in the little box there for me to show that you know how to do your equivalent fractions first. Okay, so first up we should get, we've multiplied the denominator, 3 to get to 30, we've multiplied by 10. So we'll do the same to the numerator. Multiplied by 6, multiplied by 5, multiplied by 5. The next one, E, a little different. We've gone from 63 to 9. We have divided by 7. So we'll do the same to the numerator, and we'll get 3 over 9. And the last one, we've times by 7 there, 35 over 42. So well done if you got those right. It's important you know and can work on those equivalent fractions to make your job a lot easier when it comes to adding and subtracting with different denominators. Okay, so here's the first example. We're going to do half plus 1/3. Okay, so we need to get a common denominator for this one first. Lowest common multiple for this is 6. Going through 2, 4, 6, 3, 6 from multiplication tables there. So now we need to put them as equivalent fractions. So a half is the same as 3 over 6. We've multiplied by 3. A third, 3 to 6, we're going to have to multiply by 2. So do the same numerator, is 2 sixths. Now we're back to a far simpler task, adding them together, 3 over 6 plus 2 over 6. Same denominator, so we just add our numerators, 5 over 6. Please make sure you're writing this down as it appears in your book for these examples for me, please. Next one, 5 and 4, running through your 5 times table. 5, 10, 15, 20. 20 appears in the 4 times table. Let's take that as our lowest common multiple. Get the equivalent fractions, add them together there, and we've got 13 over 20. Okay, last one. The only thing you've got to be careful here is we've got a subtraction sign rather than addition. So running through your times table, 6, 12. 12 is in the 4 times table. Let's take that one. Equivalent fractions first. 10 minus 9. And we are left with 1/12 for that last one. Okay, so based upon those, and that is the technique we're going to use. You're going to find your lowest common multiple first, get your equivalent fractions, then rewrite them and add it all together or subtract where possible. You're going to work out those ones for me there. So if you pause the video there, write out the question fully, get your lowest common multiple and show those there. Okay, hopefully you've had a good go at those 6. Those are your answers appearing on the right there. And if you can mark that work for me now, and then just note any corrections as well. If you have made a mistake, see if you can have another go at them, because in the answer, obviously shows you the best common denominator that you should have used. Okay, moving on then. 3 over 10 plus 3 over 5. Now I like a question like this because there are 4 answers and there's a reason why we've put those 4 answers down. Okay, so I want you to work it out using that method and draw a diagram to convince me that that's correct as well. Okay, so apologies, I had a quick jumping of the gun there. So what we should get as an answer for that is if we go with equivalent fractions and put them as a common denominator of 10, we will get 3 over 10 plus 6 over 10, which gives us 9 over 10. Okay, is there though more than one correct answer there? Well done if you'd recognise that already. But if you haven't, just pause the video and have a little look to see if any of the others are equivalent. And at the same time, if you're getting rid of some of the answers, why may someone have put that as an answer? Okay. So the other correct one is D. That's an equivalent fraction to B. You simply multiplied both sides by 5. The numerator and the denominator by 5 gives you 45 over 50. Now the other 2 are wrong. A, I believe they've just simply added the numerators, 3 plus 3, and then they've added the denominators, 10 and 5. 6 over 15, so that would be wrong. C, 6 over 10, they may have recognised that the common denominator should be 10, but then they forgot to do the equivalent fraction. 3 over 5 goes to 6 over 10 itself before you then add the 3 over 10. That's a very, very common error, is not to do your equivalent fractions. You've got to make sure if you change the denominator, you turn it into an equivalent fraction. Is it possible to subtract a larger fraction from a smaller one? What type of answer would you get? And where would this then be on a number line? Okay, so again, if you pause the video and give yourself 30 seconds just to think about that question for me. Okay, so a quarter minus a half. Now again, if we went to the equivalent fractions, a half is the same as 2 over 4. So 1 over 4 minus 2 over 4 would actually give us a negative. That is minus 1/4. That is fine. We can use negative fractions. So you leave that as negative 1/4. Where would this be on the number line? Well, we'd actually have to extend the number line to the left-hand side. If we think of it like temperature, if we're on a minus, we're getting smaller than 0, so we'd have to build that number line to the left-hand side to have minus a quarter there. Okay, 2 minutes I think is generous on this, but we'll see. How does this diagram represent 3/4 plus 1/6 equals 11 over 12? Okay. By using equivalent fractions, show your steps to calculate the answer numerically. Can you find more than one way to do this? So it's very similar to the diagrams we used earlier. So if you pause that again and have a little look to see if you can see where that may have come from. Okay, so that far left-hand side is the one that represents 3/4. Hopefully you can see we've got 3 columns there. 4 columns in total, and we've then coloured in 3 of them. So 3/4 for that one. On the next one, we're saying that represents a 1/6. Okay, in total there are 12 smaller squares. So a 1/6 of those we would need as an equivalent fraction 2/12. So there are 2/12 in total. Okay, adding those on to the original one, those same coloured squares, means we've then got in the total one, if you add them up, 11 are coloured in out of the 12, so we've got 11/12. Okay, and then if you do it numerically, what you may have gone with is seen the common denominator of 12, got equivalent fractions, so you'd have 9/12 plus 2/12, and again that gets you to 11/12. Okay, nice bit of purposeful practice, and I've split them up for you. First batch, adding fractions, second batch, subtracting fractions. So they've all got different denominators, so you're going to have to work out first step, the common denominator, then get your equivalent fractions, then do the addition. So that's probably, I'd say, 6 or 7 minutes work there for you. So if you pause the video, and then I'll give you some answers. Okay, welcome back then, Year 7s, and here are some answers for you. Okay, so if you mark these as you're going through, those are the addition ones, and then the subtractions. And again, if you mark that, and if you've made an error, put in the correct answer, and the correct answer will help you a lot, because the denominator in the correct answer is the one that you should have used to get as your common denominator. So then that gives you a chance to go back and do any corrections from that then. Okay. This is a lovely, what we call the non-standard example, because now we've got it written down in some words. This is more like what you may see in some exams as you go through your mathematical career. So in a bag there are red, green and purple counters. 3/8 of the counters are red, 1/6 of the counters are green. What fraction of the counters are purple? Okay, so for this one we must know that all of the red plus the green plus the purple is what makes up the entire bag, and the entire bag is out of 1. We just count that as one whole one. Much like if we said rather than counters it was pizza, like at the beginning, if we have one whole pizza, someone takes 3/8, someone takes a 1/6, whatever's left is however much pizza that person got. We're simply swapping to counters this time. So if we then fill in the fractions we do know, red is 3/8, green is a 1/6, purple is the one we don't know, that's what we're trying to find out, and we know that all equals 1. So we need to get, got different denominators, we should recognise straight away, we need to get our lowest common multiple to get a common denominator. Okay, and I think 24 for this one. 8, 16, 24, 6, 12, 18, 24 we would go with. So common denominator is 24. So let's then convert those and get equivalent fractions. We have 9/24 plus 4/24, plus then we must know the purple is also out of 24. And that altogether equals 1. 9/24 plus 4/24 is 13/24. So we know that then the remaining section must be purple, so 1 minus 13/24 would leave us there with 11/24. So 13/24 would take away, sorry I haven't finished the last line there of working, so together the red and green represent the 13/24. And that would mean then that the purple would be 11/24. 11/24. Sorry, that bottom right bit's a little bit confusing there. 24 minus 9 minus 4 is clearly not 13. I was trying to show 9 plus 4 was 13. 24 minus 9 minus 4 would leave us the 11, which is what we need. 11/24 is purple. 11 over 24 is purple there. I'll correct that after this video. Okay, a couple more of these purposeful practice, difficult, wordy questions then. Okay, so if you pause it there, have a look at number 7 and 8, write it down as a nice calculation, and then it looks a lot simpler, but it's all about getting common denominators. So first up again, in a book, 1/12 of the space of the pages is photographs, 2/3 is text, the rest is diagrams. So the whole book represents 1. If we take away the other fractions, 1/12 and 2/3, and we can go with a common denominator of 12 for those, that would leave us then 3/12 of the book would be diagrams, or we could call that 1/4. For the second one, 3/20. 3/20 would have come by car, because if we use common denominators of 20, we've got 12/20 walked, and then 5/20 came by bus. Okay, so the rest must come by car, which is 3 over 20. 9 and 10. 10B is quite a tricky one. So I want you to take a little bit longer on this one and see how much you can get done of 10B. Now, for the first one, John's given 1/4 away, spends 2/3. That means he has saved 1/12. Doesn't ask you to give the amount, but if you have worked out as well, well done. That is £50. In the fridge, 2 cartons of milk. How much milk is there altogether? So that's 2/3 plus 1/4. Gives you 11/12 of a litre. For the second part, we're told we want both cartons contain the same amount. How much milk was poured into the carton? I've simply put an answer here. On the next slide, we'll go through it in a little bit more detail. Okay, so 5/24 is poured from the 2/3 of a litre one to make them equal. Okay, and I say, now, next slide, we'll go through that in a little bit more detail. So from part A, we knew there are 11/12 of a litre altogether, 2/3 plus 1/4. Okay, and we're told they both need to have the same amount. So 11 over 12, we need to divide that by 2, so they've both got exactly the same amount. Now, because we're dividing by 2, we're not dividing the denominator, because we're not looking for an equivalent fraction here, we're simply looking at how much each person has. So, like, we know that if we've got half a pizza, and we're going to share that between 2 people, you'd get 1/4 each. Okay, so in this case, if we divide it by 2, we get 5.5 over 12 litres in each of the milk cartons. But also we should know we cannot have a decimal on a fraction. It doesn't work like that, so we need to get an equivalent fraction from that to get rid of the decimal. Simplest way to get rid of a 0.5 is to double it. And this time, because it's an equivalent fraction, we're not changing the value of it at all. We're going to multiply both the numerator and the denominator by 2. Doing that, we get 11 over 24. So from that point, we know each carton of milk must contain 11 over 24 litres to be equal. Equivalent fraction time, 2/3 of a litre is equal to 16 over 24 litres. 1/4 of a litre is 6 over 24. And remember, we're trying to get to that magic figure of 11 over 24. So to do that, we're going to need to take 5/24 away from the 16 over 24 and add it to the other one, because 6 over 24 plus 5 over 24 gets us to 11 over 24. Okay, so we would need to take 5/24 away from the 2/3 of a litre, as we'd shown on this previous as the answer. Okay, so we've got, I believe, one question after this, so we should know, hopefully by now, how to understand and use equivalent fractions. We've done some conversions between those. Add and subtract fractions that share a common multiple, so that's when we worked out our common denominator, and then we can work it in theory with those worded ones with any denominator that's been put in front of us. So very last one, which is a nice good challenge question. Jane has 3 bars of chocolate. She gives 3/5 of a bar to one friend, 7/10 of a bar to another, and 1 1/5 of a bar to another friend. Okay, so we've got a mixed fraction in there now. How much of the chocolate does she have left for herself? So I'd like you to pause the video now and have a go at that. If you're a little bit unsure, in about 10 seconds, I'll put up a hint for you as well. and then we can see how we did. Okay, so hint-wise, if you convert that mixed number to an improper fraction, then carry on as normal by getting your common denominators. Okay, so hopefully then, yes, most of you have had a good go at that, and that hint helped a little bit. But let's have a little look then to see how much Jane would have managed to get off that chocolate. Okay, so we're looking at 3/5 plus 7/10 plus a fifth. Okay, that's how much chocolate she's given away, and we need to add those three together to see how much of those 3 bars she's given away. Now, if we convert the mixed number to an improper fraction, to do that, you multiply your integer, the 1, by the denominator 5, add the numerator, which is 1, and that'll get you 6/5. So 3/5 plus 7/10 plus 6/5. We're adding fractions with different denominators, so we need a common denominator. I think the most obvious one here would be 10. We can rewrite that as 6/10 plus 7/10 plus 12/10. Adding those together is 25/10. Now, at this point, we could leave it as it is, or we could convert it to a mixed number to make it even clearer. 25/10. How many 10s go to 25? That's 2, with a remainder 5, so 2 5/10. We know Jane has got 3 bars, so we can do 3 minus 2 5/10, leaves us 5/10, or, again, you may recognise as equivalent fractions. If we divided both by 5, that's 1/2. So Jane has only got a half a bar of chocolate for herself. Jane would appear to be very generous, especially at this time of Easter. And that then is the end of the lesson for this week. So I hope you're feeling a little bit more confident on adding, subtraction, fractions, both with same denominator as for the first lesson and now with different denominators. So keep up the good work then, Year 7, look after yourselves and take care.